Good morning, geometry students. I hope this finds you well. Today you're scheduled to take your quiz over 10.1 to 10.3. Please show your work on this quiz if you want full credit. I need to know what you're thinking, why you chose your answers. So you either need to explain it in English or with math if you want full credit. Okay? So you do not have a homework assignment other than the quiz, but I thought I would go ahead and make a video just reviewing some of the concepts that we've talked about. This will go over the practice problems on page 703 in your book. So, the first thing, the formula from this section, we have a lot all over areas. I wrote the perimeter definition there and also the circumference. Please make sure you have all of these. When you're taking your quiz, you will need all of them. Areas of a triangle, parallelogram, rectangle, rhombus, square, kite, and circle, and regular polygon. Remember, a regular polygon will have all sides and all angles congruent. So the first question, you just find the area of the parallelogram. The important thing about this question is understanding that the height is equal to this right here. It's not the smaller side. In addition, the base is the larger side of the parallelogram. Okay? The height will be the distance from the top to the bottom, not the smaller side. Okay? Question 2 and 3, we are using our area formulas. We're given the area, we're solving for another variable. So we just do simple algebra to solve for the variable that we want, and then plug in our numbers and do the math operations. If you want to go over these in more detail, I'm always available on Zoom. So the area of a rhombus, number 4, is a little bit more complicated right here. We are given one of the diagonals right here. We need to find the other diagonal, the one that's going from here to here. To do this, we're going to take advantage of the property of kites and rhombuses that they have perpendicular diagonals. So we can create that right angle shown there, which will have a hypotenuse equal to the side of 5, 1/2 of the diagonal, and 1/2 of the other diagonal. We use the Pythagorean theorem to solve for A. We get A is equal to 12. We know it's equal to 1/2 the diagonal, so it's 24 is the diagonal. We plug it into the formula for a rhombus, 1/2 diagonal 1, diagonal 2, and we get 216. 6 and 7 are very easy. We're just using the formulas for circumference and area of a circle. Circumference is equal to the diameter times pi. The diameter is 2 times the radius. Area of a circle is equal to pi times the radius squared. We just plug the numbers in, we're good to go. 8 and 9 are our multi-step problems where we're finding the areas of regular polygons. Remember, our ultimate goal of this is to find the apothem and perimeter so we can find the area. The first one, they're giving us the apothem. Whenever we're doing these problems, we're going to be setting up a right triangle that looks like this, with 1/2 the polygon side on the smallest side, the apothem on the second largest side, and 1/2 the central angle forming the top angle. All your triangles will look like that. Remember, the formula for central angle is equal to 360 divided by n. For a hexagon, it'll be 360 divided by 6 because a hexagon has 6 sides. Half of that is 30. Then we can use the tangent because we're using the sides that are opposite and adjacent to this angle. When we do that, we get 6 the square root of 3. We get 2 the square root of 3. My bad. Anyway, after we do that, we find our perimeter, which will be 6 times the side. Then we plug the perimeter and the apothem in, and we get our final answer. 9 is very similar, except we have a pentagon, so our central angle will be 72. Half of that is 36. They're giving us the side, so we can easily find the perimeter by multiplying 5 by the side because a pentagon has 5 sides. That'll give us a perimeter of 60. 1/2 of 12 is 6. So our triangle will look like the one on the right for this problem. We take the tangent of 36 equals 6 over A. We get our A for the apothem is equal to about 8.258. And we just plug those in and get our answer. 10 and 11 are like what we did yesterday, where we're finding the areas of composite figures. Composite figures are composed of many different simple shapes. The first one is composed on the left of a triangle, a square, and half a circle. So we find the area of each shape respectively, and then we add the area of the square and the triangle and subtract the area of the circle. So the triangle's a little tricky. In the book, it shows you that it's an equilateral triangle where all the sides and all the angles are congruent. So that'll mean when we split it in half, it'll form two isosceles triangles that are 30-60. We can take advantage of trigonometric ratios, the special triangle, or the Pythagorean theorem, and they'll all give us the same answer, that our height, this part of our special triangle, is equal to 6 the square root of 3. Now we just plug those into our formula for the different shapes, and then we subtract the half circle from the square and the triangle. If you'd like to go over this in more detail, please let me know. We'll go over it in person. Number 11 is a lot easier. We have a large rectangle, R1, and a small rectangle, R2. We subtract R2 from R1, and we get our answer of 144. Once again, guys, please, I have not heard almost anything from you. I would love to hear from you. Please tell me your questions. Communication is the most important thing. So communicate, show your work, and I will see you on Monday.